Hello. I'm going to try to record these blog entries because speaking is a lot easier to me than typing. So while going through the web, I found this article on how hard it is to securely erase SSDs. For those who aren't familiar with what an SSD is, this is a solid-state device. USBs can be considered solid-state devices. They have solid-state hard drives, no moving parts, just chips. So the change between a conventional hard drive or a magnetic hard drive and a non-magnetic hard drive is no longer are they susceptible to magnetic fields like dedowsing, which is one of the means of securely erasing. By dedowsing, you introduce a strong magnetic field that takes all the ones and zeros. To be more exact, it changes the position of the magnetic poles that make up the information on the magnetic disk. Since flash drives aren't affected by that, you really can't take a handheld dedowser or a huge magnet and run across there. It's just not going to work. It's not going to remove any data. So another method is to fill up all the blocks on the disk with ones, zeros, or whatever pattern you prefer. That really doesn't work with solid-state devices either. Some vendors, in order to speed up access, use a type of compression. In order to use compression, you have to have available space. There are some drives that actually have twice as much space on the drive than it is available to the actual user. So to explain this, if you have a 8 gig SanDisk drive, there conceivably could be 8 gigs of additional space on that drive that's just used for the drive, so it can access and write data faster. This is great and all if you're worried about speed, but when it comes to sanitizing your media, it's not so good because it's supposed to be brand new, clean, nothing there. Some of the vendors have unit level commands that are supposed to automatically erase all the data. During testing by the University of California, let's see, what department is this? You can hear the paper rustling. I actually printed out this article. Their Department of Computer Science and Engineering, they found even though those commands are there, data is still present on the storage device. This was verified by them actually disassembling the solid-state device and putting it into a board that's specifically designed to check to see if the data was still there. So unless you're ultra geeky, more geeky than I am, you're probably not going to run that test. This was introduced, I believe, back in the 90s with the ATI drives. I remember hearing about the vendors that put this in to more easily erase, can't see the air quotes, data off of drives. But again, this depends on the vendor and whether they implemented it or not. They tested 12 drives and most of them it didn't work, failed horribly. So overwriting data. Overwriting technique, according to them, doesn't work either. For one, it's way too slow. One drive took 140 hours for 20 passes, and there was still data. So I'm sure that you would be more than a little bit peeved if there was data still on the drive. You spent 140 hours. Wow, amazing. So that's 2 down that we usually use for magnetic drives. The best hope, surprisingly enough, is to encrypt the entire drive, and then when you're ready to sanitize it, erase the encryption key. Problem with that is sometimes when you issue the command to erase that drive and it's supposed to erase the stored encryption key, wow, as they prove, the vendors didn't do it. There is a hybrid approach called SAFE. I'll have a link to this article so you can look it up, that actually sanitizes the key storage area, then performs an erase of each block on the flash storage, and then goes back and verifies. How great is that? Now, single file sanitation is even worse. Deleting a file system, which anybody that has deleted a file and has any good tools in their toolbox knows that deleting a file, especially on NTFS or FAT, really doesn't help you. 94% recovery. Other methods of single file sanitation by DoD, the Brits, Russia, Macintosh, U.S. Army, Air Force, still leaves anywhere between 1 to 84% of the data still on the SSD. Even overwriting it, even overwrite after you delete it, and overwriting the free space, I can't believe this, 100 times, about 87% of the data is recoverable. Now this varies with the amount of, free space on there, but this is really amazing that I know I carry at least 6 flash drives, and you still can recover it. So why is solid state different than, say, magnetic drive, the ATI drive? Well, with solid state, they introduced a flash layer. So what this is basically is like with NTFS and FAT, there's a table, in solid state's case, a layer, that's actually mapping where this information is, that's not really accessible. There is a methodology to scrubbing all this data out of the FTL. With this being said, can you use solid state devices as a means to recover images? Sure. Can you have them forensically found by this data? If you go up on the stand and say that, oh yeah, we sanitize our solid state disk and make sure nothing's on them, someone that read this article by, again, the University of California's Department of Computer Science and Engineering, in cooperation with the Center of Magnetic Recording and Research at the University of California, could bring your evidence into question. Well, that's all I got for today. If I went anywhere off track, or if anybody else has any additional information, let me know. I hope you enjoyed it. Talk to y'all later. Bye.